Hello students, now in this video we're going to discuss product rule of differentiation. Before we start, we have a question that if we have y equals to x sine 2x, or if we have e power 3x cos 2x, or x square natural log of 2x plus 8. Now x is basically represented by a family of polynomial function, and sine is representing family of trigonometric functions. Similarly, if I have one like exponential function and one trigonometric function again, or if I have one function as like polynomial and one as logarithmic function, and they are coming in product, then what is the process of differentiation, how we are going to differentiate such functions. Okay, so for that particular thing we need product rule of differentiation here. And for example, if we say we have y equals to u dot v. Okay, now u is representing your first function, v is representing your second function. So product rule is derivative would be equal to first function as it is derivative of second plus second as it is derivative of first. So this is known as product rule. We differentiate u first and then v as it is, or v and then u as it is. Okay, so u dot dv by dx plus v dot u du by dx, right? So this is known as product rule of differentiation, right? If we have u and v, like we have two functions and they are coming as a product, so differentiation would be u dot v prime, that is like u dot derivative of v plus v dot derivative of u. Usually simply we write it as u dot v prime plus v dot u prime. That is when we have u and v, two functions, as a product. Okay, so let's take these examples. X sine 2x. So if I have, maybe we have to differentiate x into sine of 2x. Now you see x is representing as u and sine 2x is representing as v. So first function as it is derivative of second derivative of sine 2x plus sine 2x as it is into derivative of first function, right? And you simply differentiated. Derivative of sine 2x is basically cos 2x into derivative of angle plus sine 2x into derivative of x is 1. So my final answer is 2x cos 2x plus sine of 2x. So this is basically derivative of x sine of 2x, right? So that is derivative of x sine 2x. Another question, that is e power 3x cos 2x. So derivative of e power 3x cos of 2x. Now if you see, this is my first function, let's name it u, and this is my second function, let's name it v. So that is equal to first function as it is derivative of second derivative of cos 2x plus second as it is cos of 2x as it is, and this is your derivative of e raised to the power 3x, right? So that is going to be e raised to the power 3x into derivative of cos 2x is going to be minus sine of 2x into 2 plus cos 2x as it is into derivative of e power 3x is e power 3x into derivative of power. So minus 2 e raised to the power 3x sine 2x, sorry, plus 3 e raised to the power 3x cos of 2x. And definitely we can take e power 2x common. So e raised to the power 3x taken as common, so it's minus 2 sine of 2x plus it's 3 e power 3x taken as common, and cos of 2x remains. Now this is your answer, and this is how we differentiate if we have two functions as a product, and we have another function x squared natural log of 2x plus 3. So find the derivative of x squared natural log of 3x plus 5. Now again we will consider this as u and this as v, right? So we have first function as it is, derivative of second is derivative of natural log of 3x plus 5, right? Plus natural log of 3x plus 5 as it is, and derivative of x square. And now we differentiate it, that is x square into, now natural log of 3x plus 5, its differentiation is 3x plus 5 into 3 into derivative of angle, plus natural log of 3x plus 5 as it is into derivative of x square, that is 2x. Now we can take x as common only, and what remains is 3x divided by 3x plus 5 plus natural log of 3x plus 5 into 2. So yes, so this is a product rule of x square into natural log of 3x plus 5. Is that clear? So this is the product rule. Reason of applying product rule is if we have two different families of functions, x representing polynomial functions, sine representing trigonometric functions, so x into sine 2x makes it a product of two different functions. We apply product rule, that is simply u dot v prime plus v dot u prime, or first function as it is derivative of second plus second as it is derivative of first, right? So we can try another question as well for this. So let's do one more question representing product rule. So for example, if we have to do x plus 5, for example, they want us to apply product rule to differentiate this function. Okay, so we have like this is u, this is v, right? So you can say that, okay, first function as it is, derivative of second, so that is derivative of x square plus 7 plus second as it is into derivative of first, that is x plus 5, right? This is equal to x plus 5 into 2x plus x square plus 7 into 1. So that makes it 2x square plus 10x plus x square plus 7. That makes it 3x square plus 10x plus 7. So this is your final result of product of these two functions. Okay, I hope it's clear. We have another question, x square e raised to the power 2 minus 5x. So now if we differentiate it, this is first function as it is, derivative of second, that is e raised to the power 2 minus 5x, plus second as it is into derivative of first, that is x square. So that is going to be x square e raised to the power 2 minus 5x into minus 5. I hope you remember e power 2 minus 5x derivative is going to be e power 2 minus 5x into angle, derivative of angle or power, plus e raised to the power 2 minus 5x into, that becomes 2x. So what we can do is we can take x and e raised to the power 2 minus 5x as common, and we are left with minus 5x plus 2. Or you can, rearrange it in the form x e raised to the power 2 minus 5x into 2 minus 5x, right? That is your answer. Okay, sometimes they give such questions or functions and they want us to find out stationary point. So from your AS, find the stationary point. So if you remember, what was stationary point? Stationary point was a point on the curve where dy by dx equals to 0. So for example, in this question, they want us to find out stationary point for this curve. So the derivative we got, that is x e raised to the power 2 minus 5x into 2 minus 5x, we have to put it equal to 0. Okay, this is for stationary point. Stationary point. ठीक है जी, this is for stationary point. So now either x is 0 or e raised to the power 2 minus 5x is 0 or 2 minus 5x equals to 0. So your final answers would be either x is 0, this is not possible, and this is 2 is equal to 5x, x is equal to 2 divided by 5. Now either x is 2 by 5 or x is equal to 0. So in exam, in questions in which you have to apply product rule, you have to put that derivative dy by dx equals to 0 in case when they want us to find out coordinates of stationary points, right? And whatever x values you have, you go to the original equation and you substitute those values in the original equation to find corresponding y values, right? Okay. Here's a question from past paper. The equation of a curve is y equals to x sine 2x, where x is in radians. Find the equation of the tangent to the curve at the point where x is pi by 4. Okay, first of all, remember we need to find y coordinates before we solve for equation of tangent. So if y is equal to x sine 2x and x value is pi by 4, so we put y equals to pi by 4 into sine of 2, that is pi by 4. Now this will become pi by 2, so that is pi by 4 into sine of pi by 2, that makes it 1, pi by 2, that makes it 1. So your y value is also pi by 4, right? So basically we are trying to find out equation of tangent at pi by 4 and pi by 4, right? And equation of tangent is always y minus y1 equals to mx minus x1. Okay, so now what we do is we go back to the original curve. Y is equal to x sine of 2x, and we need to find dy by dx. Now dy by dx is basically slope, so dy by dx, now we have to apply product rule here. So it says first function as it is, derivative of second sine of 2x plus second as it is sine of 2x into derivative of first. Now here it is x into cos of 2x into 2 plus that makes it sine of 2x. So this is 2x cos of 2x plus sine of 2x, right? And we need to find derivative at x is equal to pi by 4. Now this is your dy by dx. Now 2 into x is pi by 4, right? Into cos of 2 pi by 4 plus sine of 2 pi by 4, pi by 4. That makes it 2 2s are 4. Okay, now pi by 2 cos pi by 2 will become 0 plus sine pi by 2 is 1. So slope is equal to 1 and point is pi by 4 and pi by 4. Hence equation of tangent is going to be y minus y1 is equal to mx minus x1. So y minus pi by 4 is equal to 1 x minus pi by 4. So y is equal to x minus pi by 4 plus pi by 4, that cancels. So y equals to x. So this is y is equal to x is equation of tangent to the curve at pi by 4 and pi by 4, right? So you can apply product rule in such questions in this manner. I hope you got it. In my next video, we are going to discuss quotient rule now. Okay. So till then, see you. Don't forget to subscribe my channel for new videos. Okay. Thank you.